So today we are going to be working on finding the midpoint of a line segment, find the distance between 2 points, find the area of a polygon, and show that a triangle is a right triangle. So we got several learning targets here. So given 2 points, -4, -1, and 6, 3, find the distance between the points and find the middle of the segment. So let's go ahead and let's graph this out. These nice ordered pairs here, -4, -1, and then 6, 3. And then I'm just going to go ahead and connect those dots so you can actually see the line. We want to know what the distance is from those 2 points. How far are those 2 points apart from? You can't just count the boxes because it's not a horizontal line or a vertical line. So we could use the Pythagorean theorem on this. So I could go ahead and draw out a nice right triangle here if I wanted to. And then count the squares this way. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I use my Pythagorean theorem, this being A, because they make, and this being B, because they're the ones that make the right triangle. So Pythagorean theorem, if you remember, is A squared plus B squared equals C squared. My A there being 4, my B being 10, and we're trying to find the hypotenuse of C there. So this gives me 16, 100. Add them together, we get 116 equals C squared. I want C, not C squared, so I'm going to take the square root of both sides. 116 can be broken down as 4 times 29, and the square root of 4 there is 2. Cannot find the square root of 29. So that would be my distance between those 2 points. So distance equals 2 square root of 29. And then midpoint. Midpoint would be that we're trying to figure out where the middle of this segment is. And I'm not sure where that would be. Maybe here, I'm going to guess. It looks to me like it would be a nice ordered pair. It would be a ordered pair that's halfway between that point and the other point there. So my guess would be that the middle would be, looks like 1, 1. I'm going to guess. All right. There's actually formulas that we can use to figure out these. You don't have to use a Pythagorean theorem. There's another formula called the distance formula. And then to figure out the middle there, we can use what's called the midpoint formula. So let me show you those. So there's my distance formula, and there's my midpoint formula. So distance formula, you take x2 minus x1, and you square those. Then you find the difference between your y coordinates there, and you square those. And then after you find the sum of those two, you go ahead and you find the square root. Then the midpoint formula is you x1 plus x2, so you add your x's together and then divide that sum there by 2. You add your y's together and divide that by 2. So if we went back over here, we could do the same thing with these. We could actually use our distance formula on these. So let's see, distance is equal to this being my x1, this is my x2, this is my y1, this is my y2. So the distance formula says the square root of x2 minus x1, so that's 6 minus a -4 squared plus y2 minus y1 squared. So now we have those minuses, and those can become pluses. So we get 10 squared plus 4 squared, which again is following what we did down here, gives us 116. You take the square root. 116 can be broken down as 4 times 29. Square root of 4 is 2, and we're left with a square root of 29. That would be your distance, which we already figured that out using the Pythagorean theorem. So you can start to see how the Pythagorean theorem and the distance formula are Pretty much the same thing. And then our other piece there is to find the middle, so let's use that midpoint formula. The midpoint formula said to go ahead and add your x's together and divide by 2, and then you add your y's together and divide by 2. So your x's there, if I do that, it'd be a -4 plus 6 divided by 2, and it would be a -1 plus 3 divided by 2. So -4 plus 6 there is 2. -1 plus 3 there is 2. And so we get the same, what we guessed there was 1, 1, and it actually is 1, 1. So again, midpoint and distance formula. So let's go and look at an example here. So we've got this, we've got -3, 6, and we've got 11, 8. We're going to plot the points, we're going to find the distance between the points, and then we're going to find the midpoint of the segment that joins them. So I'm supposed to plot the points, 1, 2, 3, 1, 2, 3, 4, 5, 6, and 11, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and up 8. So I'm going to plot the points. I'm actually going to connect them as well. We're supposed to find the distance between them, and then we're supposed to find the midpoint. So if you prefer using the Pythagorean theorem, you could use that. I'm going to go ahead and use the distance formula. So this is my x1, y1, my x2, y2. So distance formula says to subtract your x's. So I can take 11 minus a -3 squared plus subtracting my y's, 8 minus 6 squared. So I've got this minus a minus, which becomes a plus, so I really get 14 squared plus 2 squared. 14 squared there is going to give me 196. And I've got 2 squared there, which is 4. And that gives us the square root of 200. And the square root of 200 there doesn't come out nicely, so I'm going to break it down. I'm going to do square root of 100 times the square root of 2. I can find the square root of 100. It's 10. I'm going to write down square root of 2. So there's my distance. That's part B. So part A there I plotted. Part C now I'm trying to find the midpoint. So the midpoint formula says add your x's there together, so -3 plus 11, and then divide that by 2. And then I'm going to take my y's, 6 plus 8, and divide by 2. So -3 plus 11 there is 8. 6 plus 8 there is 14. Now I'm going to divide those by 2, and I get 4, 7. So then I like to go back up here since I plotted these out. Let's see if those are reasonable answers. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Now if I would have drawn mine out more accurately there, but that definitely looks like it's in the middle of that line segment. I just didn't draw it out as accurately, so it's a little bit off. All right, so that is the distance formula and the midpoint formula. So now I want to look at some area formulas. Our area formulas there are for the rectangle, if you remember, is area is equal to length times width. For a triangle, your formula is area equals 1/2 the base times the height. A parallelogram is the area equals the base times the height. And I'm actually going to add another one in here. A trapezoid area equals, you can add your bases here together. So you can do 1/2 the sum of the bases times the height. Oh, yeah. So there it is. So you can do 1/2 the sum of the bases times the height, or some people will go like this. sum of the bases times the height and divide by 2, either one of those. So those are some formulas to bear in mind as you end up doing some of your assignment problems as we go through some of these examples as well. So the first one here is to find the area of a parallelogram. We're asked there to draw the parallelogram there out, so you want to draw it out on a coordinate system since they gave you ordered pairs. So let's go to -4, 2. So 1, 2, 3, 4, 1, 2. And then we got 3, 2. It helps when you label these as well. It helps you to keep the points there straight. 2, 3, 4, 5, 1, 2, 3, 4. And then -2, and not 4, 1, 2, 3, 4. So there's my parallelogram. So we know that the area of a parallelogram is equal to the base times the height. Well, you can just logically see, the nice thing about drawing this out, you can start to see what these are. So I could use my distance formula and find out the distance there from A to B. Sorry about that. But I could also just count on my coordinate system here. So if I were to count on my coordinate system here, from -4, 2 here, all the way over here to 3, 2, 1, 2, 3, 4, 5, 6, 7. I can just count the full squares there. So I end up getting 7 for my base. And again, what else could you use? You could use a nice distance formula. So if I were to use the distance formula, -4, 2, and we've got 3, 2, you could go ahead and take your x values here. So -4 minus 3 squared plus your y values. And so doing this, we end up getting a -7 squared plus 0 squared. And that gives us -7 squared there is 49. Take the square root, you get 7. So you can always use your distance formula if you have a hard time counting on your coordinate system. All right, height. Height, again, I would look here. How far it is from the base up to the top here? Well, it's 2. I can definitely see that. So my area here is my base, which is 7, times my height, which is 2. So it's 14 square units. So it's it makes it easier if you can draw it out and if you can see the values on there. So this one here, again, I would draw out the triangle. So -3, -3. And then 5, -3. And then -4, 4. So this one's C, this is A, and this is B. So if I connect them,